Hello everyone. So the next type of problem is a sway analysis. Okay, so in the given problem, so it's a frame wherein it is subjected to a swaying of the frame. Okay, so the question is use Carney's method and analyze the frame. Okay, now again in exam they will not mention whether it is sway or non-sway. You have to just see the framed structure and decide whether it is a sway or a non-sway. Again, just by seeing this here, I of the columns is same. Okay, B of beam it is 4i. All right, and the load here is eccentric. Had it been exactly at the center, then it would be symmetric, and that would be a non-sway. Now that the load here in BC is eccentric, so it is a sway type of a frame. Okay, then again the steps would be same as usual. First finding the fixed end moments, then calculating the first finding fixed end moments, then rotation factor. Now because it is sway analysis, there is one additional step that is called as displacement factor. That is what you have to find out, followed by the rotation contribution and the final moments. Okay, all right. So in this way analysis, okay, so you can see here first as usual the first point, that is fixed end moments. So in fixed end moments, so mfab mfba is equal to mfcd is equal to mfdc, that is equal to 0. All right, next mfbc is equal to, again it's eccentric, so minus wab square by l square, and mfcb is plus wa square b by l square. So you'll get the fixed end moments. Okay, next is finding the rotation factor. Okay, so when finding the rotation factor, it would be joint, joint B. Okay, so in joint B, it connects BA, BC, right? BA, BC. Next, similarly, joint C, CB, CD, CB and CD. Okay, so we'll calculate one by one. So first, joint BA. So in joint BA, again, it is K is 4EI by L, and BC 4, again it is all treated like a fixed support unit, so it is 4EI by L. Then add both of this, so you'll get summation K, that is 4EI. Then C, CB, CD. Okay, so it is 4EI by L, 4EI by L. So it is, we add both of this, 4EI by L. Okay, then find the rotation factor. So rotation factor is nothing but it is that is minus 1 by 2 summation k by summation k by summation k. All right. Next, once you find this rotation factor, there is an additional step which is called as displacement factor. Now, displacement factor is nothing but when the sway happens, when this complete in the column, this frame, when the sway happens, either the frame will sway to the right or to the left. Now, if it sways to the right, okay, if it sways to the right like this, okay, it is moving like this, the complete frame is moving to the right side. Now, because it is moving to the right side, BC will be straight. There is no deflection happening in BC. The only affected members are AB and CD, because once this way happens, obviously these columns will bend like this. A remains A, B changes to BC dash, and again D will be fixed. C moves to C dash like this. Okay. Now, because there is a sway happening here, so we'll find the distribution factor. So distribution factor we'll find mainly for the columns only, because the columns are subjected to sway force. Okay. So here AB. So AB again 4EI by L, even DC, because it is a fixed support, it is 4EI by L. Okay, then add only of these two, only the columns you should add here. Okay, so it is add both of this is 2.66 EI. Okay, so again displacement factor is nothing but minus 3 by 2 K by summation K. Minus 3 by 2 so K by summation K. So use this formula, then you'll get minus 0.75 minus 0.75. So this is the displacement factor. Now, these are the additional displacement factors you have to apply to the column. That is the different thing about sway analysis. Okay. So these you have to use. Okay. Now how to use? All right. See here again. The process starts from B to C. All right, because first is the joint is the B, left top corner. So it's like, it starts like this: joint B to C, then comes to the column D and A, like this. This is a cyclic process. Now, because it is sway, there are rotation factors, displacement factor in A, B, and CD also, that will be applying here. Okay, now see here, process starts from B to C. After finding rotation factor, displacement factor is also found out. Then horizontal equilibrium of the first story after taking a section through it is shown as story shear. Okay, now there's something called a story shear. Okay, so you have to first find the story shear. That is nothing but it is sum of moment of all the horizontal forces. Now to find the story force, you need to find the story moment. Okay, story moment is nothing but it is story force SR, or it is also called as story shear, story shear force into HR, okay, divided by 3. All right, see here, it is like this. Story force we need to find out, H height divided by again 3. Why 3? Because it is again you're taking the height of the member. Okay, so now story moment is 1/3 of story shear story into HR, and this should be equal to 0. Okay, now how to calculate this is, you see here, when you're calculating this distribution displacement contribution. Okay, now see here, first as usual we'll do the cycle or in rotation contribution, that is minus 67. So it will occur here minus 67.5, and this is plus 22.5. Okay, then there are no moments here. There are no moments. Okay, so there are no moments in this column section. All the moments here, everything here, the moments and all in the column are 0. All right. So now, and the 67.5, 22.5, I'll write it inside here. Okay. Next thing is minus 67.5. Okay, into this. We'll start with the first cycle. So always starts with B, C, then comes to D and B. Okay, so it is minus 67.5. So far end there is nothing here. This is because it's the first step, into minus 0.333. This is the answer. Again same thing, minus 67.5 into minus 0.167, 11.272. Okay, this is the first step. Now we'll go to the next step. So next step is 22.5. Okay, now far end there is already a moment which I've calculated just now. So 22.5 plus this is the far end. Okay, with respect to C, B is a far end. So 22.5 plus 22.477. Okay, into minus 0.333 into minus 0.067. Both the moments. You have to add both of this and distribute here. Okay, all right. We have calculated these. So this is 1, 2, 3, and 4. Okay, immediately after this first cycle, you have to immediately calculate the distribution factor. Now we know that there is a displacement factor which is occurring in AB and CD. So it is occurring in AB and CD only in the columns. So what I'll do is, you can see here only one side. Okay, clear, one side, outer side I've shown highlighted here and shown this displacement factor 0.75. Here also it is minus 0.75. Both the cases I've shown here displacement contribution here. Okay, so now we have to use this. So 1, 2, 3, and 4 is the first cycle is done. Okay, now we have to apply the same thing. Now according to the formula, if you want to find out the displacement contribution, it is nothing but it is the displacement factor into rotation contribution at the top and bottom of the column of A, B, and C, D only. Okay, now according to the formula, okay, we'll write it's here. According to the formula, it is okay, rotation contribution of the first cycle. So first is the displacement factor. So displacement factor is minus 0.75. Okay, into, open the bracket now. displacement factor we know 0.75, open the bracket. Then rotation contribution at the top and the bottom. So rotation contribution at the top of this column AB is 11.272, bottom of AB 0. All right. Next, here again top of C it is minus 7.5, bottom of C 0 rotation contribution. Okay, that is what is written here. Okay, so it is displacement factor into, open the bracket, rotation contribution at the top, bottom, at the top and the bottom. All right, close the bracket, multiply this. So it is 2.829. The same one is here also, if you are doing it for the same, because it has the same displacement factor. So it is same here, right? Okay, next. After this, one cycle is over, complete cycle. So it is applied to the beam column as well as this columns here. Next, come to second iterations now. Second iteration is again this, come to this point. So it is now minus 67.5, minus 16 point, minus 67.5. Then we have already found out this, minus 14.977. All right. Okay, minus 14.977. Okay, so minus 67.5 minus 14.977 into minus 0.167, write this answer, 13.77. Similarly, minus 67.5 minus 14.977 into minus 0.333. Answer, you write it here. Okay. Similarly, come to second, 22.5. Then previously we have got this as same. We have already calculated here now. Second iteration, 27.464. Okay, into minus 0.33 minus 0.167. Okay, so whatever answer you get, you write it here. So it is minus 16 for this, minus 8.343. Okay, now this is the second iteration, second cycle we have found out. That is 13.773, 27.464, minus 16 and minus 8. Okay, now the same thing should be calculated for the columns also. You can see it for this column now, because there is a distribution factor. Again, same thing. Displacement factor, that is minus 0.75. Then open the bracket. So once you open the bracket, it is like rotation contribution at the top, that is 13.773 plus 0, then minus 8.343 plus 0. Then it is minus 4.072. Same thing here. So like this, the same iterations should be carried out throughout. First, fixed end moments, far end, whatever is there in the far end, take that far end moment, then multiply with the rotation contributions. Similarly here also, fixed end moments, then rotation, fixed end moments here, then rotation contribution from the far end, then multiply with this and this. Okay. Then simultaneously you should start with the column moment also, because you have displacement factors in the columns also, that should be calculated here simultaneously. And now this iteration should be done until you reach the same digit. At least there should not be any differences. So more or less in the Carney's method, it will be like the third or fourth step you end up with the problem, with the solution. All right, so once you calculate all of this, then is the time to stop. After that, calculate the final moments. Okay, so the final moments is, again apply the same formula, that is moment M is equal to fixed end moments plus 2 times near end plus 1 time far end. Okay, so and once you mark this here, it's better you write off the moments here. So this is BA, BC, CB, CD. Okay, and this moment is again now AB, BC, AB, and this would be DC. Okay, so go on applying the formula here. Go on applying the formula and you'll get the formula is same thing. Near end 2 times near fixed end moments, 2 times near end moment plus 1 time far end moment. Okay, all right. That's all for today. Thank you.